guys, need your note sheet from yesterday. Note sheet from yesterday.
Oh, shoot.
So we're finishing it up. If you haven't started the homework, that's fine, because we're going over the last part of 2.1 today.
But then we have time to do the homework.
You should. We're not. The last thing, two things we want to talk about. One of them is, all right, guys, focus in, is the vertex. Vertex is the smallest, lowest, or highest, biggest point on a parabola. It is the bottom of the U. Now, we know it's going to be the highest point if the graph opens down. So you don't have to write this here. So the graph opens down. The vertex would be this highest point. If the graph opens up, the vertex would be the lowest point. It's that highest or lowest point on the graph. Now, vertex is helpful, especially when we start trying, if we're going to graph it or we're graphing these functions, because it gives us a starting point to graph it. We go 2 points to the left, 2 points to the right, and we have the 5 points needed to graph the parabola. Now, the vertex is the point h comma k. When we have the values of h and k, we can actually identify the vertex. So, before we get started with the last part, so you're on the page that has this here, yes? So I need, so right below it, where that little blank spot is.
Ooh, Kel, you're on the wrong page.
Oh, shoot.
We're going to add something right there, okay? So we're on that page. Looks like this here. So what we're going to add, find the vertex. I think there's one up there.
So we need to add all of those spaces into the box.
Yep, so that little space right there.
G of X. You know how much I hate G of X?
So right there.
My G of X is pretty cool.
Yep. All right, guys. So vertex is the point h comma k. All right, guys. Let's focus in. All right, guys. All right, guys. So, all right, guys, focus. What we're looking at is g of x equals 1/2 x minus 1 squared. So what we need to find first is the values of h and k, because once we have the values of h and k, we have the vertex. We just have to plug it in. H is our value inside the parentheses, the number being added or subtracted from x. And it's going to line up with our x minus h. We'll fill it in. So we have 1 there. So h is 1, but the question is it going to be positive or negative? It is positive 1. X minus h, x minus 1, our x and minus line up. So the value of h is indeed positive 1. Our value of k comes from outside. What number is being added to the parentheses? Nothing. So the value of k is 0. Now, we talked about transformations and how far it was moved up or down. We wouldn't list anything because moving the function up 0 or down 0 doesn't move the function anywhere, so we wouldn't list it. But as the vertex is a point, and 0 is a location on the graph. So having a k value of 0 still works. We just fill 0 in for k and 1 in for h, and that is our vertex. The vertex is the point 1, 0 for this here. All right, guys, let's look at the second one. G of x equals x plus 10 squared minus 3. The value of h, our number for h would be 10. Would it be positive 10 or negative 10?
Negative 10.
Would be negative. Because for it to match the general form, x minus h, the only way we could go from x minus h to x plus 10 is if that value of h is negative. Because our negative and negative would give us that positive, so the value of h is indeed negative 10. What's our value for k? Negative 3, because plus k outside, so the number lining up, or that's in place of k, is minus 3, negative 3. So our vertex is the point h comma k. Our h value is negative 10. Our k value is negative 3. So the vertex is the point negative 10 comma negative 3. Because h would indeed be negative 1. Because even though it does give us x plus 1 inside the parentheses, we understand that h has to be negative. So negative 1. K is nice because minus 5. K is negative 5. So our vertex is the point negative 1, negative 5. Right. Questions on this here? Now, if we were to graph these, or we're having to graph them, having the vertex helps get us a starting point to be able to graph from there. Now, for the most part, we're not going to have a value for b in finding vertex because the value for b and that h value interact with each other in a weird way. We're not going to mess with it. So, the other thing, the last thing we're doing today is applying these transformations to a function. Questions? Got to making sense of the h value flipping. Yeah, and it's all based off that x minus h. So when it changes to plus, that negative in the value of h causes that to switch from x minus to x plus. It's kind of funny it does that, but it's once we get our head around it, it makes a little more sense. Let's look at this here. Let G be a vertical stretch by a factor of 2, reflection in the x-axis, followed by translation 3 units down. So we want to write the rule for that function. We just want to write that function. And identify the vertex. So we're going to find the function and identify the vertex. Now our first transformation is a vertical stretch by a factor of 2. So at this point here, I'm just going to call it h of x. Now our vertical stretch or shrink in the general form is a times f of x, where a is the amount that we're going to stretch or shrink the function by. Now looking at this here, what's our value of a? How much are we stretching or shrinking the function by? 2. So the value of a is 2. So since we're stretching this function by a factor of 2, the value of a is 2. Now at this point here, we've plugged in all of our numbers for this transformation, the vertical stretch of 2, yes? So now we're going to replace f of x with what it's equal to. Well, f of x is equal to what? Because it told us that the graph of f of x equals x squared, so we're going to replace f of x with x squared. Let's sit in our chair. Now the last thing we need to do is simplify so we can multiply these together. So we have 2 being multiplied with x squared gives us 2x squared.
So everything's 2. Something like that.
Something. So we applied our vertical stretch of 2. Our next transformation is a reflection across the x-axis. Now the general form for reflection across the x-axis is negative f of x. But since we're applying it to h of x, we're just going to say that we have negative h of x. So we have our negative h of x. Guys. All right, guys. Stay forward. All right, guys. So, reflection across the x-axis is our negative h of x. Since we've plugged everything in and we've set this up, now we just need to replace h of x with its function, which is 2x squared. Now we just need to multiply through by that negative, which is just going to be multiplying the negative and the 2x squared, giving us negative 2x squared. Question? Now our last transformation is what? Followed by translation 3 units down. And the general form for translation up or down is f of x plus k. Or we're just applying it to m of x, so m of x plus k, because we're adding or subtracting the amount that we're moving it up or down. Now the amount that we're moving is 3, so the value of k is indeed 3. But because we're going down, it would be minus 3. And now that we have that plugged in, we can replace m of x with its function. And then drop the parentheses. Telling us that it's negative 2x squared minus 3. Yes. All right, guys. Questions on this here? Now, for the most part, this problem here, it looks like we just stuck the negative, the 2, and then said minus 3 on it, yes? And that's really kind of what happened. And the reason that it went this way is because of how they ordered the transformations. Because we did the vertical stretch or shrink and the reflection across the x-axis first before we subtracted the 3, it lined up just that way. And for the most part, this book in some texts, and some will say we just stick the negative 2 in for A, the minus 3 in for K, we have our function, we're done. And as long as it is listed this way, in this order, we're fine, we can do that, it works. But if they said that it was a translation of 3 units down, followed by a reflection across the x-axis and a vertical stretch of 2, it would give us a completely different function. So I don't like going over the way we just plug in for A, H, and K, we have our function, because it works in this one situation, it works as long as it's set up this way, and it works in this one case. I don't like that. I like having a method that works every time, no matter the setup, no matter where we start, it's going to work. I would rather have that than it's going to work in this case and only this case. That makes sense? We want to learn how to do it for anything that shows up, not let's learn one way for each different case, each different setup. It works. Luckily in mathematics, it works that way. Not in every area. For those of you that are in NTC for automotive, you have to learn a different way to do it for each car, for each type. It is, for the most part, it's pretty much we've got to learn each of the different methods. I would rather have one method that always works, not one that I have to critique for which one we have at each point. Now, yeah, vertex. All right, guys, vertex. Last thing we have to do for this problem, h and k. What is the value for k? Because k would be the number, and it would be negative. H. 0. H is inside the parentheses since we don't have any. H, guys, focus up here.
So 0, negative 3.
0, negative 3 would be the vertex. Guys. Questions on this here? We ready for the next one? So, let the graph of G be a vertical shrink by a factor of 1/2, followed by a translation 2 units up of the graph of f of x equals x squared. So this time, we only have 2 transformations. So vertical structure shrink, bless you. Our general form for this here is a times f of x. A times f of x. Where a is the amount that we're stretching or shrinking the function by. So what would our value of a be? A in this case would be 1/2. Now that we plug that value in for a, guys, we can replace f of x with what it's equal to, and f of x is x squared so we have 1/2 times x squared, which is just going to be 1/2 x squared. Now, the only other transformation we have for this here is our translation 2 units up. So the general form for this here would be h of x plus k, where k is the amount that we move up or down. Since we're moving up 2, k would indeed be 2, and since we are going up, it would be plus 2. So we replace h of x with 1/2 x squared. That parenthesis is in the wrong spot. We drop the parentheses and give us 1/2 x squared. Now the other half that we have to do, the other part for this here, is we do need to identify the vertex. So k, our number outside the parentheses would be 2, positive 2, and h, 0, because h is going to be inside that x minus h in the parentheses. Since we don't have parentheses, the value of h is 0. The value of k is 2.
I'm ready. No.
So the question is, where's H for this here? Yeah. So it would be inside the parentheses. So I could write it in for this one here. And what it would look like is 1/2 x minus 0 squared plus 2. Because we don't have that parentheses, we don't have a movement left or right. There's no reason for us to write x minus 0, which is just x, which is just going to be our x squared. Let the graph of G be a horizontal shrink by a factor of 1/3. Yep. And a reflection in the y-axis followed by translation 2 units up of the graph f of x equals x squared. So this one here is very similar. Very similar to what we would do for 33. So the first thing we have is a horizontal shrink by a factor of 1/3. We'll call it h of x. F of ax. So horizontal stretch or shrink is f of ax, where a is the amount that we stretch or shrink the function by. Now, because it tells us that it's a shrink of 1/3, what we replace a with is not going to be 1/3, but it is the flip. We have to flip the 1/3, which becomes 3. Because since it's at a horizontal shrink of 1/3, the actual value that we plug in is 3. Now, f of 3x, we have to replace every x in f of x with 3x. So we'd have parentheses 3x, close parentheses, squared. So we replace the x with 3x. Now at this point here, we do not need to square it. We don't have to simplify it down. We're going to leave it as 3x. We want to leave it as close to vertex form as we can, so it will still have the parentheses around that there. Right, now if there was a number in front of the x squared, it would stay there. Next one is a reflection across the y-axis. Now a reflection across the y-axis would be negative f, or f of negative x. In our case, it'd be h of negative x. So really to apply that reflection across the x-axis, we're now going to replace every x in h of x with negative x. So, what is h of it? Question? So we still have the parentheses, we still have 3, but x is now negative x. Now we would multiply the 3 and negative x, bless you, which is negative 3x squared. F of negative. So the negative for that would be inside the parentheses still.
That's what I wrote down.
You need a negative in front of the 1/2.
So this just needs to be regular f of x.
So it's f of negative x.
Yeah. Okay,
So,
so I still need...
yeah, so you replace the x in that function with negative x. Kind of, yeah. Now, I will answer that here in a second, but it is. Questions on what we've done so far? Now, it says up to. So the last thing we need is our m of x plus. Okay. The value of k is 2. And since we're going up, we will add it. M of x is what? negative 3x squared minus 2. What's the value of h? Question? What's what? So we put the parentheses here to show that we're replacing h of x with the 1/2 x squared. So we're plugging in place of it. Now, in this case here, we don't really need it because there's not a number in front. There's nothing being applied to it. I always put the parentheses around it just in case we do have, say, 2x or 2 times this, like we have here where we have the 1/2. I put it just in case we need it. Here we don't need it, so we can drop the parentheses and get here. Plus 2, so we're done. Like here, we had to put the parentheses around it because that 3 is going to have to multiply with the negative x, giving us the negative 3x squared. Here we plug it in, really we would put parentheses around it, but then immediately drop it. All right, guys, looking at this here, what's the value of k?
2.
What's the value of h?
Negative 3. No, this should be positive 2. It's 0. It's 0.
Because our value of h
It's the plus minus.
is the x minus h, so since there's not a value being subtracted from it, there is no value of h. The negative 3 would be our b value. So the vertex is the point 0, 2.
Okay, we're done. I don't think it's like that.
Questions on this here?
What else is on this technique? Huh? You. This. It's on this. It's down. They can't your root. We gotta learn about I would say most of us just don't know how to add a full song to the switch. That's what I'm trying to figure out.
Put it inside.
Put it inside.
Mhm.
The structure you have to do is
Yes. So, homework, 3 through 11 odd, 17 through 21 odd. So 3 through 11 odd and 17 through 21. All you're doing is describing the transformation. You do not have to graph it. 3 through 11 odd, 17 through 21, describe the transformation. 27 through 29. So again, you're still describing the transformation, but you also have to identify the vertex. And then 31 and 33, apply the function, apply the transformation to it, and then name the vertex.